Subscribe and click the notification bell to stay updated with the latest videos from School of Technology, Management and Engineering NMIMS in
A very good afternoon to everyone present here. I, Niharika Awasthi, take immense pleasure in extending a very warm greeting on behalf of NMIMS, School of Technology, Management and Engineering Family Indore. Allow me to welcome you all to AICTE Training and Learning Faculty Development Program on Internet of Things. The first two sessions were on knowing Internet of Things and data acquisition with IoT. Now, this session will be focusing on Introduction to Arduino Programming. Arduino is an open source platform used for building electronic projects. It consists of both a physical programmable circuit board, often referred as a microcontroller, and a piece of software or IDE, integrated development environment, that runs on your computer, used to write and upload computer code on the physical board. The Arduino programming language is a modified version of C++. Usually, we program in C++ with the addition of methods and functions. Before getting into the session, I would like to inform you all that a feedback form will be floated in the chat box, so I request you to please fill in the necessary details correctly, as the attendance will be provided on the basis of the submission of that form only. I feel extremely honored to introduce you all to Dr. Chandrasekhar Yamani. Dr. Chandrasekhar is working as a senior faculty of National Institute of Technology, Warangal. His research areas are renewable energy resources and power systems, microgrids, optimization techniques, meta-heuristic techniques, fast EV charging stations, blockchain technologies to smart grid, and power system reliability. In his career, he has published 31 international research publications and 2 national publications in reputed journals and conferences in India and abroad. He completed one research project under European Union H2020 program. He's working on one Indo-Norway project and has visited USA, UK, Scotland, Norway, Romania, and Singapore to present his research paper. He acted as a chair in IEEE FinCon 2016 held in Singapore. We feel privileged to have you today with us, sir. I now request sir to share his valuable inputs to the audience.
Thank you, madam. Am I audible?
Yes, sir.
You can see me?
Yes, sir.
Okay. Okay. First of all, thank you very much, Niharika, correct?
Yes, sir.
Okay, thank you very much. And you told many things about actually IoT. Very nice. Okay. You helped me a lot. Anyway, first of all, I would like to thank the NMIMS and Dean Sir, Atul Banglawala. Okay, thank you very much for inviting me. Okay, but only thing Niharika told that, okay, I am going to talk about the programming of the Arduino, but no, okay, not only that one. I am going to tell the several implementation aspects of the IoTs, okay, starting from the sensors, the various sensors. First of all, Niharika, can I know about the audience for this program? I mean, their assistant professors or students.
Pardon, sir?
Yeah, the participants are what is the level? There belongs to the assistant professors or PhD students or students in MTech, BTech. Able to understand what I'm telling? Hello?
Sir, they're all faculty.
Hello, there are faculty?
Yes, sir, they're faculty. Some are PhD and some are, they've just joined.
Okay, very good, very good. Okay. And second question I would like to know that, okay, what is their knowledge in the IoT?
Sir, you can ask them, I'll let them unmute.
Yeah. Okay. I mean, Have anybody really developed any projects in IoT, a small basic? For example, in our household, if you want to control any household appliances through your IoT, Internet of Things, okay, through your mobile or any other thing. Anybody done like that? Had tried at least? Hello? First of all, am I audible and clear, madam?
Yes, sir, you're audible.
Yeah. What my question is, okay, anybody tried that IoT implementation projects in your home itself, okay, in your home or in your work area? Okay, just like to control the any appliance, okay, control any appliance or any field work. Okay, for example, in your home, if you want to, I mean, you can yourself can build the. I mean, you can put the one video camera in your home, and you can see the camera feeding in your phone. Okay, like that, so many applications are there. Have you ever tried at least? Yes or no? Want that? Yeah, good. Chat box. Yes, sir. In UG project, very nice. one answer from the chat box is in UG project they did. What about the others? Okay, at least do you have interest to learn those things? This question you can answer. The previous question may not. Okay. Do you have interest? Okay, we have almost how many people? 87 participants, including me. Okay, I'm getting 4 or 5 yes. Okay, very nice. Okay, so this session will be definitely helpful to you. Okay, because whatever I'm going to tell everything in a practical way. Okay. Okay. First of all, before going to, I mean, if I tell something, what this is that one, but you don't have any knowledge on the basic IoT, then everything will be useless. Okay? And my teachers always tell that, my teachers, Professor Saidu sir and Saiya Kumari madam, okay, those are my PhD guides. Okay, they will always tell that whatever you tell, okay, participants should understand the thing. Okay, otherwise there is no use to you and as well as the participants. Okay, those who are listening students, I mean, there is no useful to you as a teacher, similarly no use to the audience. So that's the reason I always tell you that whatever I told, okay, it's a big thing or small thing, it's a small content or big content, okay, I want to tell in a clear and crisp way. Yes. Yeah, I'm sharing my screen. Are you able to see?
Yes.
Yeah. Okay. Yes. Okay. First of all, I hope everybody know that what is meant by IoT, right? In the morning session, hope it will be over. Correct?
Yes, sir.
Okay. Okay, if you don't know, also no problem. I will tell you in a, I mean, there are so many definitions for the IoTs, but a simple definition is you can easily assume that whatever you're seeing, all the devices, okay, all the devices, all the things, okay, the thing may not be the electrical, okay, because if you want to control, definitely you need to connect that thing in the electrical circuit, right? But if the thing is doesn't have any electrical thing, then what we will do? We will convert that into electrical, okay, by some means. Hello. Any time if you are unable to understand the things, just chart, write in the chat box or talk to me, okay, directly. Then I will explain neatly again and again. Okay. So, so anything. We are converting that into a electronic thing, first of all, okay, and after that we are connecting that into a internet. Okay? That's the internet of things. Okay? Things, many things are connected to the internet. Okay. First of all, next question we may get. I mean, we may get the next question. Why we need to connect those things to the internet? Anyone? Hello.
You can operate.
Yeah, why we need to connect? Hello, madam, am I audible?
Yes, sir.
Yeah, I mean, you want a participation session, one way session, everybody.
For everybody, you replies on chat if you.
Okay. I can't see those things.
Uh,
Okay.
Sir,
Let me.
everyone.
One second. Okay. Let me check that chart, madam. Okay. Yes, very nice. Okay. To get data, okay, remote access, easily accessible, real-time access. Yes, correct. Okay. The thing is, for example, anything you want to monitor and control. Okay. Anything you want to monitor or control. What is monitor? Okay. You want to see that continuously. Why you want to see that continuously? Because if any changes for that device or thing, okay, you want to take some action. Okay, I will tell you the examples. Don't worry. Okay. Yeah. So that is called the monitoring, continuous monitoring. Okay. So if you have the continuous monitoring, any wrong or at that time, at what time you want to control the thing. Okay. At this situation, correctly we need to control the thing. For example, okay, listen there. For example, in a hospital, okay, listen carefully because this is the wonderful example for the IoT. Okay. In a hospital, okay, many people are in the ICU rooms. Okay. So for that ICU rooms, we need to monitor their health condition every second. Yes or no? Right? Because they're an ICU, intensive care unit. Okay. So we need to monitor their health every second. And I mean, every second, and how it is changing also very important. Okay. Initially a small deviation in the health. Okay. Now slowly it will increase to the gradually it is deviating further, and it will be disturbance to the patient. Okay. So initially, if you're able to see the thing in the ICU, for example, in this moment, okay, if you are able to monitor that patient, okay, after 10 minutes, if you monitor the patient, by this 10 minutes, the health will be much more collapsed. Okay. So that's the reason, okay, they have so many devices connected to that patient, okay, presently, and those devices will alarm, okay. They make sound such that the nurses and doctors, those are in the room, they can attend that person immediately, right? Able to understand? Okay. Yes. So, but outside we are staying, right? Okay. For example, my father is in the hospital. Okay, how I feel outside of the ICU? Okay, I feel very tense. Correct. Okay. I feel very tense, and I want to see that my father health every minute. Actually, okay. Yes or no? Hope everybody know that. Everybody feel the same way. Okay. So if and the doctor also, for example, if the nurse is there, a nurse identified that there is some problem. Okay, and immediately by the sensors, okay, they are alarming in that ICU. Okay, so nurse immediately run to that patient and observe that these are the things. Okay, but immediately what she will do, she will call to doctor. Okay, and she will explain the things. Okay. Anything if you want to explain, there is so much miscommunication will be there. Okay, may not tell. Okay, I'm telling may not tell exactly, okay, what she want to communicate at that hurry moment. Okay, and immediately what she can do, she can photo the reports and she will need to send that. Okay. Otherwise, if we convert that everything into IoT, Internet of Things, let us assume. Okay, let us assume if everything is converted to IoT, okay, all the sensors are connected to everyone. Okay, if we are staying outside that ICU unit, okay, we can see our relatives' health, okay, in our mobile. Okay, otherwise in our some other way. Your wish. Presently, we are the wonderful device with in our hands is the mobile. Okay, so if you can see directly what is my relative health condition in our mobile. Okay, and doctor also immediately when the when there is a signal is changing, okay, the sensors are activating. Okay, health is not good. Immediately, doctor will also get the message through his mobile, and it will make the lesser noise in the in that intensive care unit, and immediately the concerned nurse will also get the message. Okay, if one person misses, okay, many other persons can save that patient, okay, within the IoT. Okay, and also for your surprise, if you want, that is called the monitoring. Okay, you need to check what is the health status of the ICU patient, right? Okay, and then if the doctor is there, okay, he wants to do the some action to that patient, such that he wants to give this medicine or this medicine. Okay, and for example, if I want to give that such medicine, such injection he wants to give, okay, if it is ready, one robot is there with injections, okay, it's already there. Okay, ICU patient, you know, na, okay, everything is already connected. Okay, just you need to pump inside the veins of that patient. Okay? So robot can do easily. Okay, if you send that do this injection, the doctor need not to go to the every patient. Okay, for emergency purpose, I'm telling, immediately he needs to get a particular injection. Okay, so already all the injections are set in the ICU patient. Okay, if you click one single button, okay, and nurse click single button, and it is approved by the doctor. Okay, then 2-3% redundancy purpose. Okay, we should not give the wrong injection, right? Okay, for the right injection, 2-3% are there. They're well active. Okay, because they're mobile. They will get the alert message. Okay, you can see this. This is the described medicine. Okay, and if you click that one, then it is approved by the senior doctor. Okay, if you approved by the senior doctor, within no minute, the injection will be already given to the patient. Okay, how wonder that is. And we will also get the in our message, in our phone, we will get the message that this is the injection given to your relative. Okay. Is that such a wonderful thing or not?
Yes.
Hello. I mean, messaging everyone.
Supposed to do not give permission to unmute.
Hello, madam. Madam, I mean, give the
Yes.
permission to unmute themselves.
Sir,
Madam. They can unmute and talk.
So they can unmute themselves if they.
Okay, okay. Yeah. So that much we can do using the IoT. Okay. Now this is the one example we are considering. Okay. Then how to implement that one? As engineers, we need to tell that how to implement the scenario in a physical field. Okay. So for that, let me explain with the one thing. Okay. One simple thing I will explain. Let me share with another one. Yeah. Okay. See, you can see my slide, right? So what we want, we want to control a device. Okay. One object. Okay. Or thing. I want to control. I mean, don't think that the patient is the object here. Okay. The sensor is the object here. Okay. The pulse or health condition is the object. What I am talking about. Okay? So object need to monitor and control. Okay, that is there. Pardon me for my writing. Is it okay? You able to understand? Object need to control and monitor. Okay. So how I get the information from that object to object? We have the some sensor. Okay, what is meant by sensor? Hello. I mean, if you quickly reply the thing, then we can learn a lot today's class. Okay. Yes, answer. Anyone?
Sensor is a physical component that sends the electrical signals.
Yeah, okay. The sensor is actually very good. Okay. Yeah, which can sense the signals. That is correct answer. Okay. So it can sense the signals. And what is the output? Input is the signals coming out of the physical thing. Okay. And what is the output of the sensor? Output of the sensor is information in electric form, electric signals form. Okay, that is the output of the sensor. Okay, able to understand? One signal it will come from the electrical signal coming out of the sensor. That is the sensor output. Okay, so with the sensor output, what we need to do? Okay, output is electrical signal. Very nice. Okay, with the sensor output, what we need to do? We need to check that sensor output. So we need some processing device. Processing device. Okay. Why we want this processing device? We need to check the sensor. We are getting the information from the sensor. Okay, the sensor information is within the limits or exceeding the limits. Okay, how we will know that? We need to process the data. So there is a processing device. Okay? If processing device, and after that we want the display device. Okay, display the input and display input output device. Okay, this is the one side information. Okay, from that object we are getting the information to the sensor. The sensor will convert that information to electrical signal. Okay, within the range, that to electrical signal within the prescribed range. Okay, so from this electrical signal we are processing that signal and we are understanding that what is the signal actually in electrical point of view. Okay, so that signal will be displayed in our input output devices. Okay, so what, for example, if the processing device sensor that there is a something disturbance is there, some need to do some decision. Okay, so there will be a decision device. Okay, there will be some device that should take the decision. Normally the processing and decision devices are same. Okay, in a same thing we will have both the processing and decision device will be there. Okay, okay, so this is the only monitoring thing. Okay, this total thing is the only monitoring. Okay, is it okay? Any doubts up to now?
No, sir.
No doubts, right? Okay. Okay, then what we will do is the let us do practically this thing up to this part. Hello?
Yes, sir.
Okay. So what is the object now? Okay. For example I am taking. Okay, one object is there, any physical object, no problem. Okay, my objective is to monitoring. Okay, up to monitoring we are doing, right? Okay, I want to monitor this this physical object. Okay, first of all, any object, okay, is there or not. That means that I want to detect the object, it is there or not. Any object is coming in the preview of the sensor. Okay, so I am taking one sensor. Okay, I am taking a sensor. Okay, here I am using the ultrasonic sensor. Okay. Okay, what is this ultrasonic sensor? I will explain everything. Okay, and why I am taking the sensor to monitoring a particular objective. I will explain. Okay, and the information will be converted into electric signal. Okay, that will be given to the same thing, processing and decision device. What is that processing and decision device here? Arduino. Okay, Arduino. Arduino. Okay. So this is the Arduino device. Okay, this will tell the processing and decision device. Okay, and input output display we can use just like a for input output display. I am using buzzer. Okay, so buzzer, okay, is a one type of output display. That means that if any object is there, it will give the sound. Right. Okay, let me explain clearly. Is able to understand what we are doing now practically? Okay.
Yes, sir.
There is a one sensor. Okay, that is ultrasonic sensor. I will explain what is that sensor and what are the properties of the sensor. If any objective coming near to this sensor, okay, then Arduino will this sensor will send the electrical signal to Arduino. Then Arduino will check that, process the thing, and it will take the decision, and it will give the information to the buzzer for the display. Okay, so this buzzer will make the sound. Okay, if any object coming near to the sensor, it will make the sound. Okay, so this is the simple program for monitoring anything. Okay, clear? Yeah. Before going to that, I want to tell. I mean, if madam, if 1 hour is over, just tell me. Okay, remind me.
Okay, sir.
Based on that, I will increase my pace. Huh? Yeah, I will skip all those. I will send this information if you want. Okay, there are types of sensors. So many sensors are there. Okay, infrared sensors, temperature sensor, proximity sensor, ultrasonic sensor. Okay, all these are already given here also. Okay, you ever seen this picture? No. Okay, no problem. Okay, so these are the sensors. All of you seeing me, right? Okay. Hello. I mean,
Yes, sir,
visible to
yes.
you, everyone. Okay.
Yes.
So if you see the physically, this is called that IR sensor, infrared sensor. Okay. This is infrared sensor. This is gas sensor. Is all I have all these things with me presently to show you. Okay. So this is a rain sensor. Okay. Soil moisture sensor. What we are presently discussing today, okay, that is the ultrasonic sensor. This is the ultrasonic sensor. Able to see this one?
Yes, sir.
Yes.
Yes.
Yeah, this is just in the size of my thumb. That's all. Okay, ultrasonic sensor. So today we are going to completely discuss about this ultrasonic sensor, and we will do the one experiment within the half an hour. Okay, and after that we need to control and we need to connect the Wi-Fi also. This is only monitoring, right? Okay, we need to control also. So that's the reason probably within 1 hour we will complete this one, and after that we will go for the Wi-Fi. Wi-Fi connection also. Okay. Yes. Okay, let me go to the different that ultrasonic sensor. This is the ultrasonic sensor. Able to see my screen? Yes, right? Okay. So this, what is ultrasonic sensor? Yeah, there is a different type of sensors. This ultrasonic sensor. Okay, this ultrasonic sensor is the sound waves. Okay, it will give the ultrasonic waves. Ultrasonic waves. It will release the ultrasonic waves. Okay. So you may ask a question. So it is releasing ultrasonic waves. Then what is the use? Okay, what is the purpose of this one? Okay, so that's the reason we have. If you see that these two are there, these two things are there. Okay? One is the actually transmitter, and another one is the receiver. Okay. One is the transmitter of the ultrasonic waves. That means that it will release the sound waves. Another one is a receiver of the ultrasonic waves that will receive the ultrasonic waves. Okay. Then we will get the next question. Why we need to send and receive? Okay. The problem is, okay, if you want to, if any object is near coming to this ultrasonic sensor, it can detect using this ultrasonic waves. Okay. And same time it can also detect how far the object is based on the how much time it took to return the signal. Okay, ultrasonic waves, it is sending the ultrasonic wave, right? Okay, and after that, how much time it took to reach the same ultrasonic wave again for the receiver. Okay, if it is not received, not at all received, okay, then it is the object beyond our reach. Able to understand?
Yes.
Okay. So if any wave immediately, less like sonar, very nice. Okay. The bats, the mammals, bats are there. No, okay, they will also work like this only. Okay, they will release the ultrasonic waves, and by receiving the ultrasonic waves, it can estimate the how far the object distance is. Okay. how far the object is, it can easily do. Same way it will also do. Okay, electrical. Okay, so for that purpose we need to give the some power to this device, right? Okay, I will explain this equation later. S equal to V into T by 2. At the time of programming we will see that. Okay, yeah, so this is the concept. Okay, transmitter receiver is there. Okay, if a object is there. Hello, any questions, sir? No questions. Okay, yeah, this is the picture of that zoomed picture of this ultrasonic sensor. Okay, so there is a crystal oscillator. It will be 4 megahertz. Okay, but the maximum frequency is 4 megahertz. With that 4 megahertz, it will release that ultrasonic waves. Okay, so there is a 4 pins are there. Okay, this is called a relay. Sorry, this is called a sensor, ultrasonic sensor. So it need to sense the information, and it should give in terms of the electrical signal. Okay, so for that purpose we have the 4 different pins: VCC, okay, trigger, echo, and ground. Okay, 4 different pins are there. Okay, so you can easily guess that VCC and ground are the, okay, we are giving some input information to that input power. Okay, so compulsory with that power only it will run. Okay, so that is the input power what we are giving. 5 volts VCC means in terms of voltage we are giving. Okay, 5 volts, and ground is the 0 volts. Everybody know that. So that voltage we are giving to the sensor first. Okay, and next time we are giving the trigger pulse. Okay, so how it will know that when it need to release that ultrasonic wave. Okay, so compulsory we need to give some information to that sensor. Okay, such that now we release the ultrasonic wave, and check that is there any object in front of you. Like that we need to give some signal. Okay, that signal is called the trigger input pin. Okay, so if you activate the trigger pulse, okay, again trigger pulse means what? Okay, in small voltage pulse with a smaller time. Okay, smaller time, it will be in normally in microseconds. Okay, 2 microseconds, 3 microseconds, like that. We will I mean 10 microseconds probably. Okay, like that, few microseconds we will give the some 5 volts 5 volt signals to the trigger pulse. Okay, then immediately it will release the ultrasonic waves. Okay, if once it is trigger is active, echo is also already active. Okay, output is also it is ready to receive the signals. It is ready to receive the signals. Okay, whenever it will receive the signals. Okay, then echo pin will be active. Echo pin will be high. High means echo pin will have, whenever it is receive the signals. Okay, the echo pin is giving the signal. Okay, the trigger pin we are giving the signal. Echo pin, that automatically if any object is nearby. Okay, any object is nearby, what does that mean? The ultrasonic waves already reflected, and receiver received the ultrasonic waves. Okay, that information is given from the echo. If you have echo signal is active, that means that I am receiver. Okay, I am telling that I received the ultrasonic waves. Okay, that it is telling if echo is high means. Okay, is it clear? Any doubts in this?
No, sir.
Okay, like this. Okay, I am explaining only one single ultrasonic sensor. Okay, like this you need to understand every single sensor. Okay, there are so many sensors. Immediately, okay, if for a particular objective, okay, particular program, okay, what type of sensor we want, first we need to understand. And we need to analyze that sensor completely. Okay, and we need to understand that so many things regarding sensor, because sensors are our primary connect to the real-time field, right? If the sensor data is not correct, then everything is wrong. Yes or no? Sensors are very important. That's the reason normally we have the redundancy for the sensors. No, we won't put only single sensor. Okay, 2-3 sensors we will put, such that we will get the redundancy information, more clarity on the information. Okay, anyway, so it is clear, right? Okay, this number normally we'll call this ultrasonic sensor is HCSR SR04. Okay, that is the ultrasonic sensor. This cost is almost it is probably if I'm correct 60 to 100 rupees. That's all, not more than that. Okay, yeah, and one more important thing I want to tell you is whenever you receive the any sensor, you need to understand that you need to completely understand what is happening in that sensor. Okay, so what type of what are the main parts here? If you see that transmitter and receiver, okay, technology is not contact technology, because no object need to touch that ultrasonic sensor, only waves will go and come. Okay, so what is operating voltage 5 volts? What is the operating frequency 4 megahertz? Okay, operating range. Okay, I mean I want a one particular application such that I want to detect the object 1 meter distance. Okay, if you want to go for this this ultrasonic sensor, it won't run. Okay, because the maximum range for detection this one is the 400 centimeters. That's what they are telling. Okay, so measuring angle is 30 degrees. For example, if you tell that 90 degrees angle, why it is not detecting means you need to understand the sensor. Okay, it will measure maximum of 30 degrees only. The vision for that sensor is only 30 degrees angle. Okay? Accuracy is 3 millimeters. Okay, operating current is less than 50 milliamperes. We need to understand the current also, because whenever you are designing the electronic equipments, you need to understand that how much current they are drawing. Okay, because you want continuously give the signal to that one. Okay, so for that, how many amperes ampere current required for that? Okay, all the combinations you need to check that total. What is the total current required for the total that electronic circuit? Okay, depend upon you need to put the appropriate battery. Okay, sensor dimensions, that is also very important, because okay, at a particular field, okay, there is only some space is there. Okay, but your sensor is in the size of the big radio. Okay, then what is the use of that? Okay? So compulsory you need to understand the everything. Okay, this is already explained thing. Okay? 10 microseconds normally will high for the trigger pin. Okay, echo pin will bounce back and receive the signal. The VCC is the 5 volts DC and the ground is the 0 potential. Okay, any doubts here? Any doubts? Okay, if you're following, just type the yes in the chat box.
Yes, sir.
Okay. Yes. Okay. And after that, next important thing. Okay. Just a second. Yes. Next important thing I want to tell you is, okay, our sensor is ready now. Okay. The next one is the processing unit. Something we need to process, right? Okay. That is the Arduino. Okay. There are so many Arduinos are there. Yeah. Here. Yeah. This is called the Arduino. You able to see? The I mean the PPT as well as in my hand. Okay, the real Arduino also I'm seeing in you. I'm seeing to you. Yeah, this is the Arduino. Yeah, all these things, whatever we are displaying to you, okay, all are not commercial versions. Okay, all are not commercial versions. Commercial version means you cannot. Yeah, which one? Mayurs are asking, could you confirm the cost on this module? Which one, sir? Arduino or previous ultrasonic sensor? Okay, Arduino is normally around 300 to 500 rupees only. Okay, because it will differ based on the second market. Okay, a sensor module, sir, I can surely tell you that okay, it's not more than 200. Okay, not more than 200. That's definitely I can tell. The exact amount I didn't remember. I can surely tell that not more than 200. Yeah, Arduino is around 300 to 500. The range will differ because where you are buying and how many number you are buying. Okay. If you buy in wholesale, it will definitely come in cheaper cost. Okay. Yeah, but all the electronics are very cheaper, not costly. That I can tell. Okay. Yeah. Now, yeah. So, do you have any knowledge in the Arduino, or can I need to tell everything? Hello. Reply, please. Yeah, if you know, okay. Okay, no means I need to explain everything. Okay, I will explain. No problem. Okay. So, first of all, what is meant by Arduino? Okay. So I already told you that from the previous slide. Okay. What is Arduino? It will be the processing device. Definitely, it will take the information and it will process, and it will after processing, it will take some actions also. Okay. Actions means how it will know that. Okay. So there will be just processing unit is there. Okay. See that this is the processing unit. Okay, the middle one. Okay. Okay, that is called Atmega. Atmega processor is there. Okay. Atmega 32. I don't know. There is different type of Arduino boards are there. There is Atmega processor. Okay. So what it will do is, okay, how first of all, how this Arduino will know that what is happening. Okay. So compulsory we need to give the information to this Arduino. Okay. Via few things. Okay. So it will take the, I hope everybody know what is analog and digital, right? Hello?
Yes, sir.
Okay. So these are the, you can see that A0 to A5. Okay, A0 to A5, those are the analog pins. Okay, those are inputs. I mean, it is acting as input as well as outputs to the Arduinos. Okay, normally Arduino cannot give the analog out. Okay, but those are also, I mean, analog in normally. Okay, analog inputs we are giving to this Arduino. Okay, and if you want to give power from the outside world, okay, then we can give the power here. I mean, able to understand that 10 number, okay, 10 number A0 to A5 is the analog inputs to the Arduino. Okay, all the, I mean, what is the sensor outputs normally is analog or digitals?
Depends on the sensor.
Depend upon the sensor. Okay, but many analog, many sensors will give the analog outputs. Okay. Analog outputs. For example, if you want a smooth thing, then you need to understand that is the analog thing. Okay? Digital thing means it will give the only 0 or 1. Okay, 0 or high or low. That information it will give from the digitals. Okay, analog things it will give from the 0 to 5 volts. Okay, a continuous signal. I hope you understand. Okay. So there will be we have 6 analog input pins. Okay, and we have 13 digital pins. 13 digital pins. Okay, in the 13 digital pins, 1 to 6 pins are the PWM pins. Okay, pulse width modulation. So we can control the, I mean, if you want to give that 7th, 8th, 12th, 13, all those things. Okay, if you want to give the 3 volts means it won't give the only 3 volts. It will give the only 0 or 5 volts. Minimum thing or maximum thing. Okay, but the remaining things, digital PWM pins, if you want, you can vary that 0 to 5 volts in between also. I hope you understand. Okay, so those are the digital pins. Okay, the digital pins we are taking as input as well as output. For a few pins you can take as input, few pins you can take as output. Okay, now what I am doing is, okay, see here, what I am doing is I am taking which pin I am taking as the trigger pin. Trigger pin means I am giving information to that. Let me explain that one, then you can easily understand. Okay, I am going to connect the sensor to this Arduino. Okay, so such that this Arduino will process something and give the signal to the what to give, where to give that signal to buzzer as per our diagram, right? as per our diagram, what we are doing, we have the sensor. Okay, we have the sensor, and after that we have the processing unit here, that is the Arduino. Okay, and from Arduino, if something, if a sensor is sensed anything, okay, then this Arduino will give the output to the buzzer. Okay, it should make the sound, right? Okay, so Arduino should get some information from the sensor. Okay, so which one I need to give? So what I am doing, giving is, first of all, okay, see that for that sensor, I need to give some information to that sensor. Okay, because what sensor we are using here? We are using the ultrasonic sensor. Okay, it is having the 4 different pins. Okay, you can see this one, right? In my hand. Okay, we have the 4 different. I mean, are you following, or am I going somewhere? Okay. Are you able to follow me?
Yes, sir.
Yes, sir.
Okay, the sensor is having the 4 pins. Okay, what are those? VCC, I already explained, na? Okay, trigger pin, okay, echo pin, and ground pin. Okay, ground pin. These are the 4 pins of the sensor. Okay, so if I am not giving trigger pin, it won't sense any object. Right, if any object is also there, the sensor will not act, because it will tell that why are you scolding me? You are not giving any information to me to sense what is in front of me. Okay, like that it will ask. So for that purpose, Arduino should give some input. Okay, let me change the color, then you can understand. Arduino first will tell that, hello sensor, okay, you sense what is in front of you. Like that it will do some signal. Okay, that is called the trigger pulse. Okay, that is called the trigger pulse. And after echo, okay, what is sensor is telling that, okay, after receiving the trigger pulse, okay, I understand that you want some information from me. Okay, so because I received the trigger pulse, the sensor will sense the thing. Okay, and as a return, it will give the echo. Okay, as a return, it will give the echo. Okay, okay, so that Arduino will need to give the trigger pulse first, and after that receive that echo pulse. Okay, if we receive the echo pulse, then it will give signal to the buzzer. Right? Clear?
Yes.
Okay, so for that purpose, what I am doing is, okay, first what I am doing, this is the connecting thing. Yeah, I will. I mean, if you want clearly what is happening inside this Arduino, okay, I will send this slides to you, everyone. Okay, then you can easily understand. Okay, what is that number 1 for the powering? Okay, number 1 for the this hedges. Okay, this frequency, this crystal. This is okay. This is different things are there. Okay, this is a processor. These are the analog inputs, and this is the grounds. Okay, 9 is the V input. Okay, 5 volts is the output we can take from the Arduino. 3.3 volts we can output take from the Arduino. 5 is the reset. Okay, and yeah, different things are there. Okay, this is the indicator 13. Okay, and 14 are the other indicators. LEDs actually, these all are. Okay, and these 15 are the digital input output pins. Okay, that already yeah. And 16 is the again different things. Okay, like that. This 17 the reset pin. Okay, like that everything is already explained in these slides. If you want, okay, written everything. What pin is what purpose, like that. Okay, no problem. You can see that later. Not a problem. But we need to do it practically. That's the reason I'm skipping all this. Okay. So today what we are doing is we are giving the yeah. For example, let us take the seventh pin. I am giving as a trigger pin. Okay, so it will give the trigger. Okay, when to give trigger? Next thing is, okay, I am giving this 7th pin connecting to the sensor. Okay, is a trigger. As a trigger, I am giving this 7th pin to the trigger. Okay, so again, this processor, this sensor will ask us, okay, at what time I need to give the trigger? How should I know when I should give the trigger? Okay, for that purpose, we need to decide thing. Okay, at what time I want to sense the object in front of that ultrasonic sensor. For example, can we take it is up to 2 seconds? Okay, Hello. Hello everyone. Am I audible first of all?
Yes, sir.
2 seconds. Okay. Every 2 seconds, you check that what is in front of you. Like that, I want to tell. Okay. So this trigger pulse will give every 2 seconds. Is it okay? Okay. And after that, the echo pulse is coming from the echo pulse. Okay. So where to connect this echo pulse information? So somewhere I need to connect. Okay. For example, I am connecting to this 6. Okay. Echo pulse is connected. Okay. This VCC, this should be energized. The sensor should be energized. Okay. Otherwise, it won't work. So VCC, where to connect this VCC? Okay. So where we have some V5 volts are there now. Okay. Connect here 5 volts. Okay. And I mean this ground is connected to ground. Okay. Anywhere, no problem. I can connect here this ground. Okay. This ground. Okay. So this connection is over. Okay. And after that, I need to tell that. Okay. Every 2 seconds, you need to send the trigger pulse to the sensor. Okay. Whenever you receive the echo pulse, okay, echo pulse, you need to on the buzzer. So for that onning the buzzer, I want one more thing, right? Okay. So where to one? Yes. Okay. Let us take 8. Okay. 8th pin, I am connecting to the buzzer. Okay. And I am telling that, okay, whenever the 6th pin is echo pin, right? Whenever 6th pin receive the signal, give on the 8th, right? Yes or no? Anybody not understand? It's very simple logic. Okay. I'm energizing the sensor through VCC ground. Okay. I'm telling the sensor to every 2 seconds you send the signal and check that what is the object in front of you. Okay. Whenever you receive the echo signal, okay, then you activate the 8th button and energize the buzzer and make a sound. Oh, you are unable to see the screen up to now? Oh God.
No, sir, it's visible.
What
Your presentation is visible.
Yes, sir. Pen
Oh,
description.
no, madam. You should tell me, na, madam. Oh God. Okay, I'm sending this one up to now. You can see now, na? Arduino, everything.
Yes, yes, sir.
Oh God. It's okay. I'm very sorry. Okay, I thought that you were seeing the screen. Okay. Now it is visible to everyone. Is it okay?
Yes.
Is it clear? Okay, no problem. This is a problem with online classes. Huh? Okay, that's fine. Okay, I'm repeating one more time. Okay, this is a sensor. Now you can able to see my screen with the Arduino diagram.
Yes, sir.
Yes, sir.
Okay. So up to now you didn't see this diagram, right?
No, sir.
Oh God. Okay, that's fine. Okay. This is a sensor. Okay, Arduino and buzzer. Right. Okay. So from sensor we are giving VCC to that 5 volts. Okay, and end is given to the ground. Ground is given to the ground. Okay. The trigger is connected to the 7th pulse. This one 7th pin. Okay, and echo is given to the 6th pin. Okay. So every time it is tell that every 2 seconds. Dear Arduino, okay, send a signal to the sensor such that any object is there, please reply to me. Like that, it will send the signal. Okay, the sensor will take that one, and if any echo is there, okay, it will immediately give to the 6th one. Okay, if you receive any signal for the 6th, immediately it will give the signal to the 8 such that the buzzer will be on. Okay, it will make the sound. Is it okay now?
Yes, sir.
Okay, I'm very sorry, yaar. I thought after you were seeing that screen. Okay, no problem. Okay. Yeah. Now we are doing the practically what we are doing. Okay. Yes. Okay. For your understanding purpose, I'm changing this to You need to write the code, right? Okay, otherwise this Arduino, how it will understand. Okay. Okay, for that purpose, let me share my complete screen, then you can understand things. What I am doing, you can see screen. So now you can see my total screen, right?
Yes, sir.
Yeah, see that. So this is called already. Madam is already explained all these things. Okay, this platform is called the IDE. If you want to write the program in Arduino or in anything, okay, any IoT project implementation in our thing, okay, we'll use this platform. Okay, and this is a free platform. Okay, that is already available in the online. You can see that. So I cannot do the things. Okay. The problem is here.
So sorry to disturb you, but
Yeah.
it's reminded that 1 hour has been passed.
Yeah. Okay. Yeah, if I mean, if you're replying fast, then you can learn a lot of things. Okay. If you reply slow, okay, then you will learn a very few things today. Okay, that is depend upon you, participants. Okay. Yeah, this is the software. Okay, Arduino.cc. Okay. If you want to software, go to the software and download the thing here. Okay. Windows 7 or newer. If you are using the Windows, okay, Linux or any other things. Okay. Like that, we need to download this one. Okay, if you download immediately, you will get this type of complete thing. Okay. Is it okay? Reply is important, please. Okay.
Yes, sir.
Yeah, please unmute and talk to me. No problem. I don't bother. Okay, if there any echoes or all those things. Okay, you try to unmute and talk to me. I'm very happy if you continuously talk with me. Okay. Yeah, and I want to remove this one. Just a second. Srikant, ఒక white paper పెట్టు. Able to see my things, right? Not a proper way. Yeah, I have so many things with me. Okay. This is called ESP8266. You're seeing my screen, right?
Yes, sir.
Screen means I mean my hands and my relays, everything.
Sir,
Yes.
if you could stop sharing your screen for a few minutes so that everyone can see your
Yeah, that's a good idea. Okay.
video. Yes, sir.
Okay.
So after that, you can reshare the same.
Yes. Okay, correct. Let me do that. Stop share. Yes. Okay. Very nice. Okay. So what the things I'm using today is, okay. So I have so many things here. So many relays. Okay. And okay, these are the so many relays are there. Okay. First today I'm using the only this relay. Okay, able to see the things, right? Okay. This relay I'm using. Okay. And this is a small breadboard. Okay, this is a small breadboard. Okay, this is buzzer. This is the buzzer, 5 volts buzzer. That means that it will make the sound. Okay, if you give the 5 volts, it will make the sound. Okay, and after that, I'm using the Arduino. Okay, this is a hero of the today's picture. Okay, Arduino, and yeah, that's all for the initial experiment. That is fine. These 3 things. Okay, and I'm using the few connecting wires. Okay. And to energize that board, I'm using this cable. Okay, to energize the Arduino. I mean, with the Arduino, it automatically will come with the cable. Okay, so to energize the Arduino, I'm using this cable. Okay, for example, if you don't have this cable, okay, But initially, definitely we want this cable because we want to dump our program to this Atmega processor. We need to compulsory dump our program, right? So for that purpose, we need to initially want this cable, and once we already dumped our program into this processor, and after that we don't want this type of cable. Only the power input is fine to this one. Okay, power V in. Okay. If you give the power here or power through this one anywhere, okay, if you give the energize this circuit, that is fine. Okay, but anyway, I'm using the cable to dump the program inside the Atmega. Okay, that's the reason I'm using the same cable for give the supply also. Okay, able to understand? Okay, so I will show the connections here, then you can easily understand. Okay, what I told that I'm sending the 7th pin signal. Okay, 7th pin signal to the trigger. Okay, so 7th pin I'm connecting to the trigger because my 7th one is always giving the signal to the trigger every 2 milliseconds. Okay, it will give the 2 milliseconds or 2 seconds. 2 seconds. Okay, every 2 seconds it is given a trigger such that you check that what is in front of you. Okay, so and what it will give whenever it is receiving the echo. Okay, it is giving the signal to the 6th pin. I received this signal like that, it will give the to the 6th pin. Okay, and I already told you. Yeah, so 8th pin I'm using as a buzzer pin as the output. Okay, so buzzer will be active. I mean, check that there will be plus minus for the buttons. I mean, this buzzer. Okay? So I'm connected to that one. Okay, and after that there is the. I mean, we need to energize this ultrasonic sensor. Okay, so for that VCC is connecting to the this 5 volts, right? Okay, and next one is buzzer secondary. I'm connecting to the ground. You need to count that. Okay, 8, 9, 10, 11, 8, 9, 10, 11, 12, 13, and ground. This is the ground. Okay, if you have any confusion, just count and connect it. Okay. Yeah, there's another one is the ground wire. Ground thing is connected to the ground again. Any ground, no problem. Okay, so the connections are over. Any confusion here? Hello.
No, sir.
Okay. Clear? Is it perfectly clear?
Right, it's clear, sir.
Okay. Now I'm going to write the program. Just a second. I'm stopping. I'm sharing my screen. Okay. For a second, and I will write the video. I will write the program in the Arduino, and after that we will dump the thing into. Just a second. Let me share my screen. Okay, so you can see my screen, right? Hello, madam. Hello. Hello.
Yes,
Am I audible?
sir.
Am I audible? Am I audible to you?
Yes, sir.
Okay. So for writing the code of the Arduino, actually this is a basic simple thing, C++. Okay, but definitely we need to know. Yes, C++ combination. This is actually. Okay. So no problem. If you know the C, also fine. Okay, very simple thing, simple knowledge. Okay, if you don't know anything, also you can write the code. I can tell you. Okay? So we have two things. First, setup things and loop things. Okay, for our common sense also you can tell that what is meant by setup. Setup means, okay, what are the variables we want to give the things. Okay, so initialize the things, that is called the setup. Set up the things. Okay, if you want to do any program, any project, we need to set up something. Okay, those are the setup. Loop means which one you want to run again and again. Okay, that thing will be doing in the loop. Okay, so yes, first before that setup. Okay, just a second. Let me write in correct code. Otherwise it will get difficult. If you have time, madam. Time is there. Okay. Yeah, no problem. Quickly I will write. Okay. Yeah. Define. Okay. First we need to define the things. Right. Okay. So define echo pin. Okay. I'm writing that. Echo pin 6. Okay. What does that mean? Okay, whenever I'm talking about the 6, that means that will be the echo pin. Okay, defining few things. That's all. Okay, define trigger pin 7. Okay, that's fine. Okay. Next, yeah, 2 variables I'm using here. Okay. Long, duration, and distance. Okay, so these 2 variables I'm going to use in the in this program. Okay, because we need to understand that how much duration the sound wave. What is the time of that one? And from that we need to understand that what is the distance. Okay. So the 2 variables I'm going to use. That's the reason I define that those are the long. Okay. Next, in the setup, I'm going to write. Don't worry. Okay, this is the first time you are writing the thing. It is like this only. No problem. But all these codes are available in almost everywhere. You don't need to do any hard work. It is available. Yeah, first I will write the code and I will tell that what is this. Okay, so is it fine? Okay, I mean, if you want able to understand, okay, this is a setup thing. Okay, the setup means I'm defining the thing. So serial begin 9600. What is meant by that means? Okay, this is called the baud rate. Okay, how much? I mean, this is connected to that Arduino. Okay, with what rate? Okay, that is given by this 9600. This pin mode is the pin mode is we are defining that. Okay, we are defining that the particular pin is acting as a output or input. Okay, here if you see defining trigger pin as 7th, that means that 7th pin of that that one is acting as a, so for example, if you see this trigger pin, 7th pin is acting as a output to from Arduino. Okay, from Arduino. Okay, from 7 the signal is going out. Okay, so that's the reason it is acting as an output. Okay, pin mode echo pin input. Okay, 6th pin, I already defined that echo pin is a 6th pin. Okay, we are receiving the signal, that is the input to the Arduino. Okay, and 8 is also output because we need to give the signal to the buzzer, right? Okay, so all the things are over, very simple. Okay, and after that, what in the loop, what you need to write? Yeah, here if you see that, first I'm writing one function, read distance. Okay, I'm calling one function. Okay, So from that read distance, okay, what I'm doing is, yes, serial print. Yeah, these things should be in serial print. Okay. Because I want to, yeah, later also do that. Okay, presently keep this one for the later, okay, not now. I will explain what is it mean. Okay, delay I'm giving the 2000. Okay, yeah, what is meant by this one? Okay, yeah, what is meant by this thing is, okay, whatever may be the numbers we are writing in terms of time. Okay, delay is the with respect to the time. This is the inbuilt function in the in this ID. Okay, so everything 2000 means 2000 of what? Okay, everything whatever we are writing, everything in terms of can any guess? Hello. Milliseconds, right? Very nice guess. Okay, everything is in terms of the milliseconds. Okay, 2000 milliseconds means 2 seconds. Okay, so we are read distance. Okay, read distance means we'll go to the function. I will write that function now. Okay, I will write that function. Okay, and after that it is delaying the 2 seconds. Okay, 2 seconds it will delay, and after that again it will read that what is the distance. Okay, so what that read distance will return. Okay, from that we need to start. Okay, it will return the integer. Okay, some number it will return. Read distance, the function what is inside of that one. What we are writing is, okay, first, okay, in this read distance, if you want, if this read distance should work, okay, should work. How it will work? We need to find the distance. For finding the distance, what we need to do? We need to send the signal first of all. Okay, send the signal to the to which pin? Trigger pin. Okay, we need to send the signal to the trigger pin, and after that echo pin. So we check that at what time we received that signal to the echo pin. Okay, then we can by using the formula. Okay, I will tell that one. Okay, we can find the distance. Okay, so first of all, is there already any trigger pin is already active or not? How we know that? We don't know. Okay, so for that what we need to, okay, what we are writing is digital write. Okay, this is also inbuilt function. Okay, trigger pin, okay, comma low. Okay, why we are writing this one is, if any trigger pin is already active, to make that it should be, I mean, we make sure that that is already low presently, and after that we need to give the trigger pulse, right? For that purpose we are making the trigger pulse to the low. Okay. Sorry, digital write means the trigger pulse. Okay, we are writing that one digitally, we are writing to the low. Low means 0 voltage we are given to the trigger pulse. If any previous voltage is there, we are making that to 0. Okay, and immediately we cannot give the pulse. Okay, so we need to give the some time. Okay, so for that what I am doing is I am waiting for the 2 microseconds. It is a negligible time, to be frank. Okay, delay microseconds. Yeah, this is command should be inbuilt one. Yes, now it is correct. Okay, the inbuilt commands compulsory the color will change. Okay, so delay microseconds, 2 microseconds I am giving the delay, and after that what I need to do? I need to give the signal to this trigger pulse. Okay, so I'm copying and pasting here. Okay, I'm changing this low to the high. Okay, so what this command will give? Hello. Sir, everybody following, or am I going fast, or irrelevant things? Huh? Is it okay?
Okay, sir.
Okay, digital write trigger pin high. High means previously it doesn't have any signal. Now we are giving the signal to the trigger pin. That's trigger pin. Okay. So what it will give? Okay. So after that, how many seconds I need to give the trigger pulse? Okay. Just presently I'm giving for the 10 microseconds. That's fine. Okay. A little time. Yeah. After that, what we need to do? After that, I make it to low again because I need to give the pulse. Okay. So trigger pulse, if anything is there previously, I'm making that to low. Okay, I'm waiting for the 2 microseconds, and after that, I'm giving the high pulse. Okay, some signal up to what? Up to 10 seconds, 10 microseconds. Okay, and after that, I'm closing that signal. It is initial opening the signal. It is a closing the signal. Right. Okay. So now there is another function. Okay. Duration. I want to know the duration. Duration. How much duration that is? That will come from the pulse in. Okay. This is the already inbuilt function. Okay, what it will return is okay, the pulse in is nothing but immediately if the trigger pulse is low, okay, it will start counting the thing. Okay, I already told that the sensor itself is built like that. Okay, if trigger pin is active, okay, then immediately the echo pin is trying to receive the signal. Okay, so if it receive the signal, high means echo pin is high means it is already received the signal. Okay, then it will give the how much time that took to from this trigger pulse low to this echo pin high. Okay, that much time it will give. Okay, in terms of milliseconds. Remember that. Okay, the pulse in function will return the in milliseconds, time in milliseconds. Okay, so if the time in milliseconds, so what is the distance? How we know the distance? I want distance, right? Okay, so duration into 0.034 divided by 2. I am writing that. Okay, why I am writing? Any guess? The distance is duration into 0.034 divided by 2. Any guess? Okay, if no, let me explain. Okay, see that, for example, if the duration, okay, the duration is a time. Okay, time, for example, x. Okay, I already told that what is the pulse in will give? It is in terms of microseconds. X microseconds. X microseconds means what? X microseconds. Okay, into. Okay, what I want? I want distance. Right, distance equal to speed into time. Right, distance equal to speed into time. Okay, I already have the time. I need to tell the speed. Okay, what is ultrasonic wave speed? It is sound wave. Okay, so 340 meter per second. 340 meter per second. Okay, is it clear? Hello. Okay, so if you cut down this second to second, okay, so what is your output from this? 340, okay, meter. I mean x, obviously x into, okay, x into 340. Hello, 340 micrometer, right? Yes or no? Am I audible?
Yes, sir.
Okay, x into
Yes, sir.
okay 340 micrometer. Okay, but if you understand that, okay, this is the time. Okay, actually the trigger pulse is going from the what end? Okay, sending end. Okay, sending end of the sensor. Okay? And receiving end, it is receiving. So the wave should travel twice. Okay, that's the reason we have the divided by 2. Okay, if you find the exactly, we will get the 2 times of the distance actually. So if you want, but we want only 1 time of the distance. That's the reason we are divided by 2. Okay, the same thing if we want to write in terms of centimeters, you need to tell me. So you have the micrometers. You need to convert into centimeters. What to do? Same thing. Okay, x into 340 into 340 into, okay, it is in a micro, 10 power minus 6. Okay, so I am converting into 10 power minus 4 into 10 power minus 2. Okay, how will I write 10 power here? Okay, okay, we'll write 10 power minus 4 into 10 power minus 2. Okay, completely I'm writing micro. Okay, meters. Okay, divided by 2. Clear? A response, please.
Yes, sir.
Okay, if you have any confusion, just calculate and see my slide. Okay, see my program, then you can understand. The sound wave is the 340 meters per second. I hope everybody knows that. Okay, so 340 meters per second, it will run. The duration, the time is already given in x microseconds. Let us assume. Okay, x microseconds, x into, okay, 340 micro, 10 power minus 6 into meter by second. Okay, second cancel, micrometer. Okay, it will come because it's a distance, right? Okay, 340 micrometer divided by 2 because the wave is traveling twice, but we want only one distance, so divided by 2. 340 micro, if you write that 340 into 10 power minus 4 into 10 power minus 2, the 10 power minus 2 we are writing in terms of centimeters. Okay, so it is equal to x into 0.034 divided by 2. Units are centimeters. Okay, I want distance in centimeters. Okay, so that's the reason I'm writing like this. Okay, so that's the reason I written code like this. Okay, so what it will return? It will return the distance. Okay, it will return the distance, and after that, what I need to do? First of all, is that okay? Clear, everybody? Any doubts, please ask me. I will explain. Yeah, how many of you understand? Just type the yes in the chat box, please. Yes, sir. Okay, Rajnikant, sir, it will work practically. I will show now. That is the objective of our thing, sir. Okay, it will work practically. I will show now. Okay. Okay. So if you see that, if you know the simple this one, it is very easy. Okay. Now see that we are called the function read distance. Read distance is a function here. Okay, read distance is a function. From this read distance, okay, this function is calling. Okay, after that we are doing all this thing. It will return the integer. Okay, what it will return? Distance. It will return the distance. Okay, it will return the distance to as an integer to this one. Okay, and after that, based on the distance, what we need to do? Okay, we need to on the buzzer, right? Okay, so for that, what we need to do? Give the distance. If the distance, okay, less than 20, okay, if If the distance is less than 20, what I'm writing is digital write. Okay, what I need to do? I need to hide the eighth pin, right? I need to hide the eighth pin. Okay. Else what to do? Else. Okay. Else digital write 8 to the low, because for the buzzer purpose. Okay. Okay, I'm delaying for the initially and end. I'm giving the 2 seconds delay. Okay. Is it fine? Deep output code, sir. What is that? Okay, maybe you're telling that you will get the beep. Okay, okay, I'm dumping the code inside of my Arduino. Okay, I already did. Yes, let me. Yeah, I mean, I'm closing this one programming because you can see this video neatly. I am not sharing the screen. Stop share the screen. Okay, stop sharing the screen. You can see the video. Okay, the same program is dumped inside of this one. Okay, see that. Okay. Able to see? Okay, any object, put my phone. Clear? Hello? Hello?
Yes, sir.
This is the output we are expecting now. Okay. So
Yes.
now I will test that. Okay. See how far it can detect. Okay. This is far away. Slowly I'm going towards yeah, this much distance it is detecting. This much distance. We put this angle this way, then they can understand. Okay. So see the distance between my phone and the our sensor. It is detecting now. Yeah, slowly. Yes. I see almost yeah, 20 centimeters, 15 to 20 centimeters detecting. Okay. So, okay. So that is the way to do the things. Okay, are you satisfied? It's fine.
Yes, sir.
Okay. Now what we will do? What we will do is, if for any objective is there, just it is buzzing sound is coming. Okay, and I would like to know. How far the object is exactly. Okay, so for this distance. Okay, if we know what is the distance, for that we have a code that for that reason I written here. Okay, serial printing distance. Okay, it will give that how far the object is. Okay, but we should also understand that if the object is not nearby, we should tell some other thing, right? Okay. Yeah, see that. So for that it's already there, right? Yeah, let me. Okay, COM6 is not there. Okay. Okay. Yeah, for the connection purpose, see that okay, many people will confuse here. Okay, you need to connect to the Arduino. Okay, what is our thing? Arduino Uno board. Okay, Arduino Uno. What port you are connected, that is also important. Okay, Arduino Uno is COM5. Okay. Yes, Sketch is compiling now. Okay, then compiling. Yes, see that. Okay, so it is giving some random number of 400. That means that is not in the range. Okay, not in the range. Okay, for example, if you want to write for that random number some out of range, definitely you can put the out of range. Okay, now I'm putting my hand in front of the sensor. Okay, that 9, 11, 10 centimeters it is giving. Okay. Yeah, let me show that. Okay, you are seeing this. Okay. Yeah, see this. Okay. Okay, whenever I put my hand, it is giving the exact numbers of 9, 11 centimeters. Okay. Okay. Is it fine? Hello. Yeah, if you want to write the complete code, if you want, okay. If distance is greater than 1, okay, and distance is less than, let us take 20. Okay, then what I will do is print the serial monitor. Okay, else, okay, else serial.
So you wrote distance instead of distance.
Somewhere is distance spelling mistake. Then compiling, they can see the serial monitor. Okay. Okay, anyway, that's all from this one. Okay, the thing is, we don't have that much time to explain for the next one. Okay, anyhow, no problem. We have 20 minutes. I will definitely explain. Madam, can I continue?
So we have 20 minutes left.
Hello.
So we have 20 minutes left.
Yes, 20 minutes. So I will quickly go through that one. No problem. Okay. Yes, this one. Yeah. Okay. Next thing is if you see that. Yeah, I already explained that one, right? Okay. Let me in this. Let me take one new slide. Now, okay, up to now we are discussing about the only monitoring thing only. Okay, now we are going to the control thing. Okay, so we have some object is there. Okay, so we are sensing the object through the sensor. Okay, and after that we have that control device, control and monitor device. Okay, and processor, okay, processing device. Okay, this after that, okay, if you want to give it in the internet, okay. Hello, can you please mute? Somebody is okay, internet, and there is a another control, okay, decision taking device. Here it is. Okay, so these two things are connected to the internet. Okay, I want to control this object. Okay, so there is an object. I want to monitor processing. I mean, from the sensor, we are sensing that object information and processing, and after that, I need to control. But I want to the control thing. If I want to control, from the other device which is connected to the internet. Okay, so for example, if you take my phone here, my phone is there. Okay, I want to control the some buzzer. Okay, and some relay. Okay, relay is nothing but the actuator. Okay, I hope you understand what is going to be actuator. Actuator is the if you want to switch on, I mean, actuator is nothing but it's a electronic switch. If you take it, okay, it is also called the relay. Okay, the buzzer relay if you want to control. Okay, so the sensor, I'm not taking sensor now. Okay, directly I'm connecting to the my processing device. Okay, processing device. And for this internet purpose, I may use so many things here. Okay, how it is connected to the internet. Okay, through so many things. The Wi-Fi. Okay, Wi-Fi can be there, and Bluetooth is there. Okay, initially, but connected to the modem, we are using so many things. Okay, Wi-Fi, Zigbee, Bluetooth, so many things. Okay, and after that, it is connected to the internet. From the internet, we have a phone. In this phone also, it is connected to the Wi-Fi or Zigbee or any other things. Okay. So now today, what I am going to do is exactly same thing. I am going to connect my phone. Okay, for that phone. Okay, how will you know that the phone will know that it is connected to the internet, and I want to connect some buzzer and some relay somewhere. Okay, and where is that Wi-Fi module? Okay, this processing module is there. Okay, but Wi-Fi module is missing. Okay, it connected to that Wi-Fi. Okay, so for that purpose, we have the one device is there, that is ESP8266 Wi-Fi module we are using, including the processor. Okay, that is called the Node MC. This is that one. Okay. Hello, madam.
Yes, sir.
Yeah, this is the I'm audible. For the reason I asked. Okay. Okay, all of you see that this is the ESP8266 under module. Okay, the real-time Wi-Fi module. Okay, with processing. Okay, we have a processor as well as the Wi-Fi module. Both are inbuilt here. This is called the ESP8266. For your surprise, it is cheaper than the Arduino. Okay, the cost is almost 250 to the 400 rupees. rupees only. Okay, this is ESP8266. This we can take the, I mean, whatever the programming we can dump into this ESP8266. Okay, and it is acting as a Wi-Fi also. It is connected to the Wi-Fi. Okay, so I'm using that today, ESP8266. And for that phone, how will you know that? Okay, it is connected to which one? Okay, for that purpose, I'm using the one app is called Blink app, BLYNK. Blink app is there. Okay, in that app, I'm going to control this buzzer and as well as the relay. Okay, how I can connect this Blink app to this ESP8266? Okay. For that purpose, what I'm doing is, and this is a Blink app is, it's already connected to the internet. Okay, they will give the one auth token. Auth token they will give. Okay, whenever we are programming this one, we are going to connect that ESP8266 with this auth token. Okay, in the Blink app, I mean, I mean, how to connect these two? How what is the handshaking process here? Okay, there will be one auth token here. Okay, this is inside of our phone. We are generating that one. Okay, to connect to the internet. So the same thing will be in the programming of that ESP8266 with this Wi-Fi. I mean, ESP8266 Wi-Fi module. Okay, Node MCU. This is also called the Node MCU. Node MCU. Okay, this Node MCU, we are connecting this with this token as well as the Wi-Fi module both. Okay, so I will show the code, then you can understand it. And I'm going to so I mean, I am going to run the thing, and I'm going to control the buzzer as well as the one relay. Yeah, just a second. Yeah, you can able to see my code, right? Hello.
Yes, sir, we can see.
You can see my code. Okay, and in this Blink app, okay, yeah, this is the okay. So I hope you can see my mobile, right? Hello, Madam Niharika, madam.
Yes, sir.
Please keep in unmute for total class. Okay, it's only 15 minutes are there, na? Okay, don't mute yourself.
Yes, sir.
Okay, I can see my Blink app, right?
Yes, sir.
Yes, sir.
Madam, I told you to not to mute. Okay, because I want some replies. Okay, otherwise if you are not there, some other person also not a problem to me. Hello, it's okay,
Yes,
ma'am.
sir. Yes, sir. You can see.
Okay. So this is the Blink app. Okay, so in the Blink app, I created one IoT class. Okay, IoT class. Madam, that's fine, madam. Niharika, you can mute. Okay, you can mute. Okay. There is a IoT class, right? If you click this IoT class, I already designed that one. Okay, in that settings, if you go to that one, okay, what is this? I mean, name, what type of device I am connected. Okay, how I connected is a Node MCU. It is connected. I mean, at the time of installing that one, it will ask everything. Okay, Node MCU, Wi-Fi connected. Okay, I already told. No, okay, there is a AUTH TOKENS. Okay, auth tokens. It is already there. Okay. For this one, it is given that one. If you copy your email, then your email will get that token. Okay, at the time of writing your code. Okay, if you see here, in the screen, if you see the screen, okay, I'm already my screen shared to you. In the screen, if you see that the auth token already written. Okay, the same token is connected to this one. Okay, and after that, what I am doing is there is a buzzer and relay. Two different things are buzzer and relay. Two pins are there. Okay, it is connected to the D1, D2. Okay? What is D1, D2? We can on this, we can off these things. Okay? D1, D2. Okay. Okay. Yes. Okay. So this is the ESP8266. So there is the device. It is also having the digital pins. Okay, D0, D1, D2 like that. Here also we'll have the digital pins. Okay. For these digital pins, we are giving total access to this software. This software in the phone, I'm giving the total access, so that we can give the signals from this D1, D0. Okay. So the same thing I already written in the code. Same thing I already written in the code. You can